Hello guys, let us solve few word problems from maths chapter square and square roots. We are doing 4 word problems from exercise 5.4. We will be solving question 6, 7, 8 and 9. Question 6 is find the length of side of a square whose area is 441 meters square. Let us first write what is given. Area of square equals to 441 meters square and side of square we have to find. Formula for area of square. Area of square equals to side square. Area of square is 441 is given to us. So we will substitute it in this formula. We have 441 equals to side square. But 441 is 21 square. So 21 square equals to side square. We will now write square root of both sides. That means square from both sides will get removed and we have side of square equals to 21 meter. One important thing to remember, many students make mistake in this step. They start squaring 441. We don't have to square 441, we have to see whose square it is. Next step, we have squares on both sides. We have 21 square equals to side square. When you take square root of these two, squares will be removed. We will have side equals to 21 meter. Let us see what we have in question 7. In right triangle ABC, angle B equals to 90 degree. We have two sub questions. In A part we are given if AB equals to 6 cm, BC equals to 8 cm, find AC. Let this be our right angle triangle. We'll first label angle B as 90 degree and other two vertices we'll label as A and C. We are given side AB equals to 6 cm and side BC equals to 8 cm. Side opposite to angle 90, that is AC, which is also hypotenuse, we have to find. Find hypotenuse AC, we will use Pythagoras theorem, and according to Pythagoras theorem, hypotenuse square equals to side 1 square plus side 2 square. That gives us AC square equals to AB square plus BC square. On substituting values of AB and BC, we have AC square equals to 6 square plus 8 square, that is 36 plus 64. 36 plus 64 is 100. 100 can be written as 10 square. So we have AC square equals to 10 square. Remember, in next step we don't have to square, we have to find square root. So squares will be removed and we have AC equals to 10 centimeter. Let us do question 7b now. Triangle ABC will remain same, angle B will be 90, only sides, length of sides is different. Let's see what is the length given here. AC is 13 centimeter, that means hypotenuse is given to us, and BC is 5 centimeter, base BC 5 centimeter, and AB we have to find. Again we will be using Pythagoras theorem. We have hypotenuse square equals to side 1 square plus side 2 square, that is AC square equals to AB square plus BC square. But in this case hypotenuse and one side is given, other side we have to find. So we will make some changes in the equation. We have to find AB square, we will leave it alone on right side and we will shift BC square towards left side. The equation we will have is AC square minus BC square equals to AB square. Values of hypotenuse AC and one side BC we will substitute in this equation. We have 13 square minus 5 square equals to AB square. 13 square is 169 and 5 square is 25. So we have 169 minus 25 equals to AB square. 169 minus 25 is 144. So we have AB square equals to 144. But 144 is 12 square. So AB square equals to 12 square. Taking square roots of both sides, their squares will go away and we have AB equals to 12. Let us go through question 8 now. A gardener has 1000 plants. He wants to plant in such a way that number of rows and the number of columns remains same. Find the minimum number of plants he needs more for this. If number of rows equals to number of columns, the number of plants will be a perfect square. For example, number of rows in this square is 2 and number of columns is also 2. and total number of plants here will be 4, which is a perfect square. Number of rows is 3 and number of columns is also 3. Total number of plants is 9, which is also perfect square. When number of rows is 4, number of columns is 4, total number of plants will be 16, which is perfect. Now we can say if we are given number of rows equals to number of columns, the number we are looking for is a perfect square. We are given gardener has 1000 plants and how many more he needs. So we are looking for a perfect square closer to 1000 and more than it. We'll use long division method to find perfect square close to 1000 and more than it. We'll start by making pairs of numbers from right. For 10 we will use perfect square which is less than 10, like 2 2s are 4, 3 3s are 9, 4 4s are 16. 16 is greater, so we will use 3 3s are 9. 3 as quotient at the top, 3 on left side, 9 below 10 and plus 3 below on the left. Subtracting 9 from 10 we have 1 and next pair of zeros we bring down, so the number becomes 100. Adding 3 and 3 we get 6. We have to write one digit on right side of 6 and multiply it by same to cancel 100. So 61 into 1 gives us 61. 62 into 2 gives us 124. For 100 we can use 61 into 1 and quotient will be 31. This gives us remainder 39. That means 31 square is 39 less than 1000. But we want a number which is more than 1000 and a perfect square. We can do this in two ways. Quotient is 31. Next perfect square will be 32. We will find the value of 32 square and see the difference between 32 square and 1000, which is 24 in this case. We have to add 24 to 1000 to make it a perfect square. Other method of doing this will be, instead of using 61 into 61, we will use 62 into 2. That is 124. Our quotient has become 32, but we have remainder minus 24, which indicates we have to add 24 to 1000 to make it 32 square. The gardener in this case needs 24 more plants. Question 9 is similar to 8.1. Let us go through the question. There are 500 children in a school. For a PT drill, they have to stand in such a manner that the number of rows is equal to number of columns. How many children would be left out in this arrangement? Again, in this sum also we are given number of rows and number of columns is equal. So number which we are looking for will be a perfect square. But in this sum we have to find how many children would be left out in this arrangement. That means the perfect square which we are looking closer to 500 will be less than 500. We'll start by doing long division method for 500. Start making pairs from right. 5 is a single digit. We have to use square, perfect square less than 5. 1 square 1, 2 square 4, 3 square 9. So we can use 2 square 4 for it. Write 2 at the top as a quotient, 2 on left side plus 2 and 4 below 5. 2 and 2 gives us 4. 5 minus 4 gives us 1. 2 zeros we bring down, it becomes 100. 100 we will write one digit to right of 4 and multiply it by same. 41 multiplied by 1 gives 41. 82 into 2 is 84. 43 into 3 is 129. We will use 42 into 2, 84. Our quotient becomes 22 and we have remainder 16. Means 500 square equals to 22 square plus 16 or 484 plus 16. This tells us 484 children can stand for PT drill. There will be 22 rows, 22 columns and 16 children will be left out.